Well, good morning. I could see the night before's had its toll and rain and getting people out here this morning. But no problem. They say it never rains in Southern California, it pours, and I think you've seen that happen in the last 15 days or so. And we'll talk about an area that's been hit this morning by some pretty heavy rainfall. There north of that picture in this photograph on the ridgeline, they had 21 inches as of yesterday morning on San Marcos Pass, so out of this one storm. Anyway, surprising to some perhaps, there's been a lot of cloud seeding programs and operations in Santa Barbara County, California. In fact, there was a program conducted from 1950 to 1955 there, really operationally oriented program using ground generators. After that, there were some research programs, and I'll talk a bit about those this morning and try to get through this quickly. For those of you, I imagine everybody realizes where southern Santa Barbara, or where Santa Barbara County is. It's an interesting location because it's oriented to the coastline pretty much east and west, which is contrary to most of the rest of coastal California. And because of that, in these southerly flow storms, they get very strong orographic effects and can produce a lot of rainfall because of the orientation of the mountain barrier there in Santa Barbara County. Previous research programs in Santa Barbara, there was Santa Barbara 1 in 57 to 60, had some randomized ground-based survey-IODIDE seeding, indications of positive effects but not statistically significant. Fairly interesting program that I'll spend quite a bit of time on here this morning was Santa Barbara 2, sponsored by the Naval Weapons Center in China Lake, 67 to 73 in two phases. The first was randomized ground-based survey-IODIDE seeding of convection bands. And I'll show you a picture or some photographs of what a convection band looks like as it passes through the county. Indications of positive effects, some statistically significant at some of the rain gauge stations. Phase 2 was a randomized airborne seeding of convection bands again. Positive effects, some of those statistically significant at some, at some of the rainfall sites as well. Here was a network of recording rain gauges that were used in the analysis of Santa Barbara 2. I believe the number was about 120 some rain gauges that were available, some installed specifically for the program. Two places to look on this map that will be important. One being right here. This is actually just east of Reagan's Ranch on TV Peak, it's called, north of Santa Barbara, where flares were fired every 15 minutes in these convection bands as they passed over that site, identified from the rain gauge network, so they would see the bands coming in from the rain gauges originally and later on by radar. And then the second phase of the program was flying off the coast of Santa Barbara, off of Vandenberg specifically, to seed the bands on an airborne platform as they moved ashore. Typically, the aircraft is flown at the freezing level, seeding in the leading edge of the convection bands back and forth as the band moved inland. Here was an early study based on a 4-year period of 71 to 74 of the amount of precipitation that occurs from convection bands in Santa Barbara and the surrounding counties. And as you can see, it's a fairly significant phenomenon there that's producing about half to some as high as 60% of the winter rainfall comes from these convection bands. Okay, here's what a band looks like on a recent Vandenberg NextRad radar depiction. Fairly high reflectivities. They're typically oriented north to south or northeast to southwest. Oftentimes it'll be a frontal band that you'll see forming like this, and this probably is a frontal band that moves through the county. There's some terrain blockage of the radar here, so you kind of lose a little bit of detail on the band as it passes through the county. But very typically an inch or two rainfall will occur with the passage of these bands. Some of them can be prefrontal, they're usually smaller in nature, and some can be postfrontal, which are also typically smaller than the frontal band. Here was the results of the seeding based on all those rain gauge locations I showed you. It was blind to the analyst of determining the amount of precipitation that fell at each one of those rain gauge sites, whether it was seeded or not. And here's phase one, where we're seeding from this one site with 400-gram flares fired from the ground at the ridge line every 15 minutes as the band passed over the county or over this location. So you can see downwind over there indications of about a 50% increase in the band precipitation from seeding at that one site. You'll see some big numbers over here, but this is a very dry rain shadow type area in downslope flow, so even though you have a ratio of 2 there, that's not really particularly significant. These, however, are quite significant because, as I mentioned before, this ridgeline area is receiving quite a bit of rainfall in the wintertime, probably averages 30 inches to 40 inches at some locations. The statistical significance of seeding in that area is shown as follows based on individual precipitation gauge sites, some of which were significant at the 1% level, some at 5, and some at 10, and some at 5, and so forth. There were quite a bit of indications of downwind effects from this program, extending even into Los Angeles County on a separate study that was looking at downwind effects. Interestingly, the winds are typically southwest, say at the 700 millibar level, so you would expect the microphysical effects to be going this direction, but a lot of the effects seem to perpetuate down the backbone of the ridge crest, which Bob Elliott and others that had worked on this program interpreted to mean that there was a dynamic response in these bands this way, as well as a microphysical response more towards the normal expectation to the northeast. Phase 2, airborne seeding off the coastline at the freezing level, showed similar results, but a displacement of the results typically a little westward. You'll see right along the coastline then indications of increases of 50 to 100% in the bands, another area here in the central part of the county, and then again showing up in Ventura County. Those were also, some of those stations were individually statistically significant as well, some down in this area of 1%, and 5, and 10, and 5, and 1, as you can see. So also a fairly strong indication of seeding effects from airborne seeding in Santa Barbara to phase 2. Okay, the information, this came from some of the earlier reports on Santa Barbara. The conclusions that they came up with were that precipitation from convection bands can be increased on the order of 50 to 100%. These increases appear to be both microphysical and dynamic responses. The seeded bands appear to widen and possibly slow down. They actually released Raywin sounds into the bands and saw that the 700 millibar wind direction compared to the non-seeded bands seemed to back in the seeded bands. The atmospheric pressure under the bands at a distance of about 100 kilometers was decreased on the average of 1 millibar. Moving the location of seeding caused a corresponding shift in the indicated increases in precipitation. Operational programs have been going on in that area since 1977-78 when they had a drought, and they started up some operational seeding programs, typically both airborne and ground-based. It was then started again after this one season in the early 80s. It was dropped 1 year because of some fire damage in the area, but has continued to the present in that area every winter, seeding for increasing rainfall to provide municipal drinking water supplies. We've done a large percentage of these programs, and we're trying to adopt the techniques that were used on the Santa Barbara 2 research program to run the operational program. The two target areas we're really interested in are the Twitchell drainage and the upper San Ynez drainage. Each of these sites, there's 4 now, there's another one in here, are ground-based locations of the flares that we're firing. They look like this. We can control these through the internet through cell phone linkages and fire flares as the bands are passing over the site. There's an alert network, so we have both rainfall at the site and we also have the radar depictions from Vandenberg telling us where the band is located with time. Airborne seeding, we used generators as well as flares. We looked at the possible augmentation potential in Santa Barbara County. It showed that we might expect, if everything went well, a 21 or 22% increase on average. Went through some numbers with the county to see what that would be worth, and they came up with an estimate of the additional water would cost about 7 cents per cubic meter. I think that converts to about $90 an acre foot, compared to $400 an acre foot for state water, or to $1,000 an acre foot for desalination. I think that's it. Yep. All right.
We have questions for Don? Yes,
Danny.
What about this area? What fraction of that precipitation index would be caused by orography in relation to what happens just in the open ocean? In other words, what is the orographic enhancement factor?
It's pretty significant, Danny. I don't have any specific numbers on that, but it is a significant orographic influence there. And well, that's an interesting question. I'm not sure I can answer that as far as how much the bands are being enhanced because of the orography, but there probably is some enhancement there. And I'm not sure I can answer that question.
On your map showing your statistically significant field, I'm wondering, it looks very continuous.